Welcome to our session on water treatment equipment. Today, we are going to learn how to calculate the capacity of various types of water treatment systems, from basic filters to water softeners and specialized iron filters. Let's start with basic filters, like sand, multimedia, or activated carbon filters. Interestingly, there isn't a strict mathematical formula for their filtering capacity. Instead, we monitor the pressure drop across the unit. As impurities clog the media, pressure drops, signaling it is time for a backwash. Typically, backwashing every 3 to 6 days prevents the filter bed from cementing solid. Now, water softeners are a bit more precise. Their capacity depends on the water's hardness, the number of people in the household, and any iron present. A standard rule of thumb is estimating 60 gallons of water usage per person per day. We usually aim for a 3-day regeneration cycle to ensure there is a reserve capacity, so the user never accidentally runs out of soft water.
But what if the water contains iron or manganese? We have to calculate what is called compensated hardness. Every part per million of iron adds 4 grains per gallon of hardness, and manganese adds 8. If the total equivalent iron exceeds 1.5 parts per million, you will actually need a dedicated iron filter installed upstream of the softener to prevent the resin bed from fouling. Let's look at a sizing example without iron. For a family of 5 with a water hardness of 32 grains per gallon, they use 300 gallons daily. Multiply that by 32, and the softener must remove 9,600 grains of hardness every day. Over our recommended 3-day cycle, that is 28,800 grains. You would then select a softener model that exceeds this capacity. When setting up the softener, salt capacity is crucial. You might think using more salt is better, but it is actually less efficient. For instance, using 15 pounds of salt per cubic foot of resin removes 30,000 grains, which is 2,000 grains per pound. But a factory setting of 6 pounds removes 20,000 grains, yielding over 3,300 grains per pound. It is much more economical. Moving on to iron filters, the first critical step is verifying the pumping rate. If the water supply cannot provide enough flow, the filter will not backwash properly and will fail prematurely. You find this by measuring the drawdown volume in gallons and dividing it by cycle time in seconds, then multiplying by 60 to get gallons per minute. Never just guess based on the pump's rating plate. For chemical-free iron filters, sizing depends on the flow rate and the total concentration of iron, manganese, and hydrogen sulfide. You simply add their parts per million together to get the loading factor. By multiplying this factor by the daily water usage, you find the daily removal requirement, which helps you determine if the filter needs backwashing every 4 to 12 days. Seriously, manganese green sand filters require a bit more attention. Manganese and hydrogen sulfide create a higher demand for oxygen and are harder to oxidize than iron. So when calculating the load for these filters, you multiply the iron content by 1, the manganese by 2, and the hydrogen sulfide by 3. These filters typically need backwashing more frequently, usually every 2 to 6 days. To regenerate that manganese green sand, we use potassium permanganate. It is vital not to run out, or the filter will release trapped manganese and stain the plumbing. The dissolving rate is actually affected by the room's ambient temperature. You can calculate how long a batch will last by dividing the total weight by the dose size and multiplying by the days between regeneration cycles. To wrap up, correctly sizing water treatment equipment is not just about guessing. It requires careful calculation of water usage, hardness, and specific contaminants. Whether you are monitoring pressure drops in a sand filter or calculating compensated hardness for a softener, these steps ensure efficient operation and a long lifespan for the equipment.